Hello everyone. RMS value or effective value or virtual value. There are same meaning of all these things. That means RMS value, and this is the chapter 8 of NCERT. And the definition of this RMS value, the effective or RMS value of alternating current is that steady current, that means DC, which when flowing through a given resistance for a given time produces the same amount of heat as produced by the alternating current when flowing through the same resistance for the same time. Yes, it is also called virtual value of AC, and normally represented by IRMS or I effective or IV, that means I virtual. For example, we can say that RMS or effective value of an alternating current, we consider that it's 5 ampere. Okay, it means that the alternating current will do work at the same rate as 5 ampere direct current under similar conditions. Now, to prove to find the expression of RMS value, you can see here it's a DH. I'm right. Here is DH equal to I square R dt. That means for a small time interval, the heat produced in the wire, it must be DH. Okay, and I equal to I naught sine omega t. This is I equal to I naught sine omega t, as well as then put the value in instead of I, you get I square sine square omega t dt. This is equal to DH, and next for DH, now integrate DH to get the whole value of integration I naught square R and integration of sine square omega t. The integration of this sine square omega t, because sine square is a variable portion, so integrate it from 0 to t for full cycle. Okay, and then I naught square R taking out from the integration, and sine square omega t, the trigonometrical formula of sine square omega t is 1 minus cos 2 omega t by 2, and integrate this one from once again 0 to t for full cycle. Next, you can take out 2 outside from this integration, then it will be I naught square R by 2, and integration of dt, because if you multiply 1 into dt, then it will be dt, and integration of dt, you can separate this part from 0 to t, and cos 2 omega t, it's a separate another part of this portion, and integrate this one also from 0 to t for full cycle. In next, you can write again I naught square R by 2, and in the integration of dt is t. So taking limit 0 to capital T, which is for full cycle, and next cos 2 omega t, integration of cos 2 omega t is sin 2 omega t by 2, and integrate it this one for once again 0 to t, I naught square R by 2, and when you put the limit 0 to t, that means t minus 0, you can write directly here t minus, and you can take in common from sin 2 omega t by 2 omega, you can take in common from 1 by 2 omega, and then it will be sin 2, and put the value of omega, which is 2 pi by t, and putting upper limit, which is capital T, minus next you can put the lower limit sin 0, which becomes total portion of this second part will be 0, that means sin 0. Okay, in next you can write here I naught square omega, I naught square R by 2, and t as well, and you can see here t and t you can cancel from the sin 2 omega, instead of omega t cancel, sin 4 pi, the value of sin 4 pi is 0, as well as the value of sin 0 is also 0. So it will remain the same thing, I square R by 2 into T. Okay. In next, you can integration of dH is H. Now finally it will be I naught square R T by 2. Then as you know, H equal to I square RT for RMS value. You can write here I RMS, H equal to I RMS square into T. There are two equations and you can equate these two equations because there are in all these two equations have the value of H are same. So after equating I square RMS RT equal to I naught square R into T by 2. Okay, then you can cancel R and T both side and you can get the value of I RMS equal to I naught by root 2, which is equal to 0.707 I naught. Okay, this will be the final value of the effective value, you can say IRMS value or effective value or the virtual value. Got it? Thank you.